Continue being recorded. Now I share my screen.
I don't see your screen.
I haven't, hold on.
Oh, you're not shared it yet. There you go.
Is it coming through? It's clear?
Yes.
All right. So first, I'll tell you just a little bit more background. And this is, we've got an hour. If you guys have questions, you want to stop, comment, or just in general chat, I mean, all that stuff is fine with me. I'm pretty easygoing, and to me, this is more having fun than anything. I'll tell you, I started out in R&D doing computer science. My degrees are from Penn State University, but I spent roughly about a year, a little more than a year at Motorola doing R&D. And for some reason, Motorola wanted me to sit in a corner and develop network architectures and work on that. But I found it kind of, I don't want to say boring because it was exciting work, but it was very solitary work. And after that year of like really working, trying to put this thing together, Motorola canceled the project. And they canceled it because the project, we designed everything that the marketing people told us to build. But what happened was once they put it together and priced it out, then the marketing people said, no one will ever buy this. So the marketing people forgot to think that price was important. And because of that, I basically lost a year of my life working on this project. And I figured there's got to be a better way for the market to inform technical people about what they need to build. So that's when I left Motorola and I went into product management at Siemens. I was there for 5 or 6 years. And from there, I went into Alcatel-Lucent. It started out as being a part of Rockwell. It became Alcatel, and that merged into Alcatel-Lucent. And now most of that has merged into something called Nokia. While there, I spent lots of time developing products for new technologies. I did strategic planning, marketing, strategic marketing, and then eventually I was even doing global strategic marketing. So I had like 40 people spread all around the globe working with me at the time. At some point, I got tired of the industrial world, and I decided to go to work for USC, where I taught a few classes, not much. Most of my time was spent as director of the communication technology management. But I left USC, to be clear, at the end of 2019, the beginning of 2020, just before the pandemic hit, to take some of the research we'd been working on at USC and commercialize it. So that was a pretty big change for me, but that's what I've been doing since the pandemic. We are, for what it's worth, we're probably within several weeks of releasing our first product. So it's an exciting time for us, but it's also very hectic because there's a lot going on. Now, what the project, and I'll go back to sort of how the project evolved, and we've actually been working on this, started at USC in 2016. At the time, all the industry pundits were citing all kinds of numbers about how fast the IoT market was going to go, and they all had hockey sticks that they were showing, but everybody's hockey stick was different. And everybody was saying different things about how that hockey stick would begin to emerge and the evolutionary track it would take. So we were asked, one of the questions was, which hockey stick is right? But beyond that, like how inside that hockey stick can you tell the parts that are going to emerge first and provide value first? So that was the mandate, the question they asked us to research. We did. It was a pretty exhaustive process. We did a lot of primary research. We did economic modeling. We did network traffic modeling. And we came to the conclusion after lots and lots of work, we came to the conclusion that the problem was everybody was wrong. which was sort of startling to say that, but that was what we concluded. And as we dug into it further, it was that most of the people who were forecasting the market were going out and asking people, would you like to see this? Is this of value to you? And they were getting really positive response about the need, the desire, the interest in IoT. But when we were doing the economic analysis, what we saw was that the price points people were looking at were nothing close to what was currently in the market. So there was this, that was a big problem. At the time, and we were probably one of the first places to identify the importance of privacy, security in the IoT space as being a stumbling block for the market. So we raised that as a flag. And we concluded that unless these problems are solved, the hockey sticks will be very slow and muted in terms of how they evolve. We did something kind of, I think, was unusual, and that raised a few eyebrows. And that what we did is we documented our market research not as a white paper or something that would ever get published in an academic journal, but we published it as requirements, which was kind of interesting. The people at Viterbi saw the requirements that we'd put together and how we documented this. And I'll say, I can't say that it was driven by anything specific, but they just said, hey, that looks interesting. And they started building a few prototypes around it. And they evolved the prototypes, and we kept talking back and forth about, well, what does this mean? And how do we do these things? And the system just sort of naturally, organically evolved a little bit over time. But at some point, the city of LA heard what we were doing and asked us to explain it to them. And then, so it was research that was fine. We went, we talked to them, told them what we were doing. The city of LA was facing a strategic issue at the problem that they were wrestling with, in that every department in the city was standing up these IoT silos. So they would have a problem that could be solved with an IoT technology. So they would do an RFI and RFP, find who's got the best software, find who's got the best devices. They'd build that system, deploy it. But it really formed an isolated silo, the way that they were constructing it. It solved the problem that the department was asked, but what it took people had to understand, you had to have people assigned to each application to sort of understand it, to maintain the IoT devices and those kinds of things. The central IT department was trying to figure out their strategic plan. And they realized that most of the staff at the city, a number of the staff people, it was becoming a very mature IT department. So people were going to be headed toward retirement. As they head toward retirement, because of the way finances work in the city, it wasn't clear that they were going to get people to replace the retired people. So the IT department understands that they've got to be able to do more work with less people. That's good. A lot of people realize that. But they also saw all these silos in the outlying departments and understood that as those people begin to head toward retirement, the city would say, here's a silo, we still need to support it. This department doesn't have the people anymore. Let's transfer it to the central IT department and let them manage it. So they were facing this issue. They were looking at, well, we're going to have less people, and the workload that's being put on us is not just going to rise, it's going to rise incrementally. So how do we deal with that? And they saw what we were doing and thought that, well, what you're doing might provide a solution to that manpower management issue. So they started encouraging us. When every so often we would sit down with them and they would say, no, stop, don't think about it this way. Think about that problem this other way. Consider these issues while you're working through it. And over time, we started actually picking up speed evolutionarily to the point that in 2000, this was probably late 2017, we were with the city, they looked at us and we looked at them, and we realized we weren't developing just an interesting academic exercise. We weren't developing something for the city of LA, but we were headed towards something that really could have impact to the way we think about smart cities, the way we architect those networks. Based on once that light bulb went off, we created the I3 Consortium. Cher mentioned that in the beginning. The consortium is really an open consortium. Anybody can join, become a member. For the first couple of years, we were really focused on trying to make this I3 concept something that could be supported by industry, people who develop devices, people who develop by applications. So we started getting inputs from lots of people about, think about this, do this, don't do that, think about this other way, don't forget this other important aspect. So that evolved and continued to sort of help nurture the I3 consortium and this thing that we were developing. We developed the software at USC. We actually released it as open source in December of 2019. When it released, that's when I left USC to sort of say the knowledge that this software, this open source software, while it's nice, it's functional, it solves a problem, a city's not going to deploy it unless there is a support structure behind it. You don't want a mission critical piece of software to sort of crap out on you and have no way to get it fixed. So I was sort of following the playbook when I first left the university of Red Hat, saying, all right, well, here's open source. You need services behind that. Let's go off and do that. That's when the pandemic hit. So that was about March. I think we had just about got certified as a corporation in the state of California when that pandemic hit. We sat down at that point in time with, and I think there were the county of LA, the city of LA, the city of Long Beach, and talked about what we were doing. And basically the message was, for the next year, everybody in government is going to focus on healthcare, on COVID. So we're not going to be in a position to take on any new technology problems unless it helps us solve this current issue that we're dealing with. And the advice they gave us, we sort of came to collectively, was that instead of trying to push and roll out the I3 software in the midst of the pandemic, they actually suggested that we go back and sort of restructure the software to make it more reliable, resilient, more scalable, to add features that had been left off of the open source, because the open source was really designed and developed to demonstrate a concept. Whereas if you were deploying software in an operational setting, you do things differently for how do you build the user interfaces and how do you do this and how do you do that. So we spent most of the last, well, since the pandemic hit, we spent our time basically redeveloping the I3 Consortium software into something that is scalable, and it is something that's much easier to support instead of something that was co-developed by a series of students over a number of series of semesters, which was leading to parts of code that there was inconsistencies in how well it was documented, things that would have made it difficult to support that software. We're within weeks of releasing that software commercially. And our intent is to make it something that is, I mean, I don't want to say ship it out of a box, but we want to do something for the mass market to make it something that's pretty easily to order, buy, download, and get it up and running. So that's kind of what we're doing. So that gives you some history, and I think since most everybody here is sort of associated with academia, give you some background on how it evolved and how we got to this point. I don't know if anyone has any questions about that process. I think it's an interesting story, which probably applies to a lot of other efforts. Anyone? No? Well, let's talk about I3 then, and what the problem is. I mean, obviously, the world's becoming, I mean, I don't have to tell you guys this, but the world's becoming much more data-driven. So there's going to be much more data going on over time, but it's been slow. And we need to sort of evolve and start thinking about things different ways. Instead of thinking about apps being linked and tied to devices, which leads to sort of this silo mentality, which has trouble scaling, is that we wanted to sort of switch and change the way that we think about the data that flows between those apps and devices. And we basically put this idea together that there's, if you call this sort of a distributed data bus or whatever, but we wanted to have a common point so that the data can flow into a system, and then from that system it flows to many, many different applications. This does a couple of things as far as sort of the business goals, is that if you think of the other picture where you have these silos, what you're doing when a company thinks about deploying an IoT system, they look at the value of that they get from that system. And if it makes sense, they deploy it. And if it doesn't, they don't. And that's what they're supposed to do, look at the return on investment analysis. But if you can take a device so that the data from one device is driving 3, 4, 5, 6 different applications, then when you go to do the ROI analysis, instead of looking at the value of one application, you're looking at the cumulative value of 5 or 6 applications. And what that means is that there are IoT systems that under a silo structure would never have made sense to deploy financially. Suddenly they become viable. The other side of it is, and that's sort of looking at it from the device side down. The other side of it is that when we talk to people on the application side, people who are deploying these applications, some people have told us that their company spends 80% of their time trying to find data that'll support that they need for their application. And once they find it, they don't just technically hook up to it, but they've got to build and maintain relationships with the people who own those devices to keep the data flowing. And this is one vision analytics company told me that they spend 80% of their time working on data acquisition issues. So if you think about a vision analytics company spending 80% of its time on data acquisition, that means they're only spending 20% of their time thinking about the vision analytics problem, which is the thing that they're really well known for. So in some ways, I sort of think about i3 Systems as sort of us wanting to be the plumbing that lets appliances work. Plumbing gets the water to go to different parts in the house. You have faucets to turn them on and off. It's not as sexy as having a refrigerator that can tell you what's on its shelves. But unless you've got the water flowing to the system, some of the value of that appliance is taken away. So I sometimes think of what we're trying to do as being sort of the plumbing of IoT. I think that's sort of an interesting way to sort of think about what we're doing. There are some things we had to build into the solution. Besides trying to simplify those issues, we had to think about how do you test these systems to make sure they're right. We had to think about logging systems and what data do you track. We spent a lot of time looking into privacy and data security requirements and where all that was going. I've always found it interesting that GDPR was really advanced in sort of saying that you had to let people tell them what the policies were. You had to give them control over their data. You had to be able to know when and where people say yes and no, giving approval to use their data, but they never said who is responsible for maintaining those records. So of course, the application guys are the people who end up storing the records. So if somebody disagrees and says, no, I told you to shut it off way before then, all the record keeping is done by the company that you're trying to sue. So I think there's some real holes in kind of the thinking about how those systems are enforced and who has to keep the data to make that enforceable. So yeah, so that's some of the stuff that we thought about. Now, by putting I3 there, by improving the way that data is plumbed, maybe I'll keep using that analogy. We think what we do is we actually make it easier, and we'll see an acceleration in terms of how IoT devices are deployed. So that's a good thing. Certainly, if you're a carrier, a wireless carrier, I'm thinking of like the cellular providers, they see more traffic go over their network. So that's a good thing for them. Data lakes are filled easier, better, quicker. So we actually, right now, most data lakes store historic data. Whereas if you start filling data with real-time data into those data lakes, it actually shifts the way we think about some AI and data analytics, instead of looking at just how trends might be in the future so you can do better planning, so that you might identify opportunities. You can start thinking about using AI to actually automate operations of a business, because you're looking at the data real time. And these are things we think about. So even though I3 is really just a very thin layer of software in terms of what it does, it enables a whole lot of activity to occur above and below that had not been occurring or has been slow to evolve over time. So that's kind of where we're trying to get to.
So Jerry, quick question.
Sure.
So in this architecture, so where is I3 focused? Is it in the communication connectivity infrastructure? Is that sort of what you're targeting?
Yeah, and I would draw it kind of at the very top of that orange bubble. So it's almost a thin layer between the data lakes and the communications connectivity infrastructure. One of the things that we did as we were thinking about this is we tried to make sure we weren't encroaching on what people who did data lakes were doing. We weren't encroaching on what the applications were doing. We wanted to stay below that, partly because it made sure we had fewer competitors, but also too, by doing it, there's a clear delineation about what it is we're doing and where we fit. If we're trying to make all those people more applications, enable them to be smarter, if they start to look at us as competition, they'll actually opt not to work with us. And therefore then you end up back in this stalemate of sort of the slow plodding forward. The same could be true on the IoT side. And although I said we see ourselves on the top part of the bubble, we have architected the system such that we can begin to migrate and start putting some of the I3 intelligence at the edge as well. So that's all been thought about as we were sort of putting this together. Yeah, it is sort of interesting when we started thinking about IoT devices, and this is something that sort of evolved our thinking. When we started the project, we were thinking about IoT devices like you think about IoT devices. But as we went along, we started to better appreciate that many IoT devices feed into a front-end processor, and the front-end processor would feed up. So we would not actually be directly interacting with the IoT devices, but with some front-end processor. And we began also to see more and more intelligence being installed in the IoT devices. So over time, we began to appreciate, even though I draw IoT there, that really could be any real-time data source. And if you start thinking about this might have potential applications even between two applications that are trying to pass real-time data. So talking about it as IoT, it sort of helps people understand it, but the reality, I think we understand, it's actually it's bigger than that, because it's not just limited to devices. So I said privacy, security, policy, brand. A lot of what we do, and some of you know Bhaskar. Bhaskar has said, you know, a lot of what we did in release 1, what we did with i3, I mean, they got a few papers out of it, but it wasn't, let's see, it wasn't a paper-rich environment that they could get a lot of papers out of, because technically, there were a few things we were doing, but it wasn't a lot of things that were really unique. What we were really doing, a lot of the uniqueness came from our understanding about how do you create an environment that is behaviorally oriented to encourage people to want to participate in this environment. And because of that, that's why we started thinking about incentives, why we started thinking about data policies and how do you exchange data policies and use cases. So there's a lot of stuff that went into i3 that is not really technical. It's almost more marketing or behavioral, even behavioral marketing sort of focused things about creating that environment where people actually want to participate in these exchanges. And I think that's something that sort of is often overlooked about how difficult it is to motivate people to participate in these kind of exchanges. Because of that, we sort of think about 4 things as sort of being key issues, and the slide got a little messed up, so I apologize, I guess the way it got formatted for the screen. Certainly one of the things that people, before they want to do it, they do want to continue to have control over their data. I think this idea of data ownership is a bit, I always struggle with it a little bit, because data ownership is not, you can say, I own this data. Data is a digital thing. You can copy it, replicate it. So whether somebody on the other side does that or not, or makes a copy and enhances it and calls it something else, it's really tough to say who owns data. And I think that ends up into lots of real complicated, drawn out arguments that probably, if you took them to court, the cost of having a court case would probably far exceed what you might get out of bringing a suit if you said somebody went against it. I think what you need to do is create an environment where people can better understand what their data is being used for, how it's going to be treated, the benefits in it for them. And a lot of what we're doing is trying to expose that information to people. So we think of this as sort of being sort of several keys to sort of unlocking people's behaviors. One of them is sort of, they need to understand, whoever's asking or wants to see the data, what is their data policy? And the data policy should define things like, you know, how long do we retain data? Do we sell data to somebody else? Do we do this? Do we do that? So these are sort of corporate level decisions about the organization that is asking to see the data. The other key is sort of related to the use case. I might give my data for one purpose, but to a company, to an academic institution, to a government entity. But for a different use case to that same entity, I might say no, or I might change my conditions and say, well, in that case, I'll release it to you, but only if there's some incentive, some value in it back for me. So we tried to think about these things as being the keys that would encourage people, or at least make them better aware of the conditions that they're changing their data with. And incentives, that's listed as a key. And a lot of people think about monetary concessions when you say that, monetary incentives. But we think broader than that. We think about maybe you get a digital coupon, maybe there's some sort of, I don't know, a frequent data contributor model where if you earn enough points, you get to do something, but there incentives, really, there's a lot of different forms that incentives can take. Maybe if you do enough, you get a ticket to go someplace. So we don't try and limit our thinking about what form the incentive takes, but that people should somehow be rewarded if they're giving you good data that you can use. And then the last thing is about how do you deal with change requests? If I give my data, how hard is it for me to sort of say, all right, maybe there was a newspaper article about a security hack that happened last night and I want to shut that person off. How easy is it for me to go off and do that, to turn off and then maybe later turn back on those data sharing arrangements? So those are the things that we sort of began thinking about, is creating that environment where people say, yeah, you can have my data because here's what's going on. The other thing that we thought about a lot about is that if you have a solid IT department, data sharing is less of an issue. And I say that because the IT department can sort of say, here are the applications you have available to you. Here's our standard IoT device for collecting environmental data. And if you want environmental data, you can get it, but you got to deploy this device because it's the one that links to our system, and all those kinds of things that are inherent with a very strong IT department. If you have a federated IT department where the central IT department is actually more of a coordination organization, but there's a lot of decision making is pushed out into the departments, or if you're in a situation where you're trying to allow two independent companies who have a common interest to work in an ecosystem that requires data sharing, you really can't force the two companies to along the same application decision purchasing process around the same IoT. So you have to build your system to sort of operate in a very federated environment, which is sometimes very difficult to sort of get your head around. The fact that the IT department is not somebody who can actually has dictatorial control over the system that they're managing. But that's something that we spent a lot of time working our way through. So an example, and this is actually a project we're working on with the city right now, the city of LA. The city of LA, their sanitation trucks currently have between 4 and 6 video cameras on every sanitation truck. That video right now is being used basically to collect safety information. If the truck is involved in an accident, the video is recorded. They use the video sort of in the defense or to quickly settle the claim if they were at fault. It can do that. The sanitation trucks, they have these forks that lift the garbage cans in the air and empty them into the truck. It's really dangerous if you don't put the forks up and start driving. So some of the cameras are specifically looking to make sure that the drivers are actually practicing good driving behavioral processes, and because that reduces safety, that reduces liability cost. The city wants to evolve. Their first thing was the sanitation department wanted to start using those video cameras, also just to sort of build records of they picked up the garbage at this address at this time on this date. They did it here, they did it here. That way, like if citizens call in and complain and say you didn't pick my garbage up, they can go back, review the record and say, yes, we did, here it is. Or if it turns out that they didn't, they can say, well, there was a car parked in front of your garbage cans, we couldn't get to them. Or if the driver just sort of drove by because he was behind schedule, they can also identify those situations. So that was kind of the path that the sanitation department was on. But the sanitation department realized, and lots of credit to the sanitation department, that if they have these video cameras on trucks, they can do things or collect data that is not sanitation specific. For example, you can as these trucks roll around the city and they drive over every road on a scheduled basis, so they cover every street at least once a week. We've been able to show that those cameras can detect graffiti. And if it sees graffiti, using video analytics, you can then generate and send this alert that goes to, I don't know, the graffiti cleanup crew, who then goes out and cleans the graffiti that's been identified. Right now, the way it works is the only time graffiti ever makes it, the notices ever make it, is if citizens through their 311 app call and report, hey, there's a bunch of graffiti, you guys got to come clean this up. or if the city actually sends out a graffiti lookout crew and they drive the streets looking for this stuff. If they could automate this off of the sanitation trucks, the city begins to look much more proactive to the citizens, and they don't need to have these dedicated crews to go out and check on things. But there's other things too, as you think about this, that can be done. If not on a garbage day, but if there's just garbage, a pile of some big object sitting by the side of the road that shouldn't be there, those can be, that need a special truck to go get it. The sanitation truck could notice it, flag it, and the city could dispatch it. You can even do things like spot overgrown vegetation, and that might trigger an action to sort of tell the permitting people to go out and tell the people to cut their grass or give them a fine if it's been going for such a long time. So the idea that we're working towards is this idea of taking what had historically been thought of as a Department of Sanitation asset, a Department of Sanitation data stream, and turn it into a data stream that actually helps all the other city departments. Well, not all of them, but any that are a bunch of different departments. So we're turning that data stream into a City of Los Angeles data asset. And from, I don't know if anyone here is from the business school, but if anybody studied finance, if you want to improve the performance of a company, you basically increase your ability to leverage its financial assets. What we're basically saying is, just like that in data, if you want to improve the performance, physical performance, you basically leverage the data more, and because you can get more for less bang for the buck. This is a different application. This was actually our beta application that we tested with the city on. The idea here, in some parking lots in Los Angeles, they have technology. They'll tell you where the empty parking spots are. Sometimes there are lights in the ceiling. Sometimes you can get online and see them. But there's every parking lot owner, and even by parking lot, has different technologies, if they have any technology at all. The city of LA, the parking options, it's a patchwork of options. I mean, there's street parking, store parking, parking lots, there's all kind of stuff. And when people want to go to the Staples Center, you can maybe spend 20 minutes driving to the Staples Center and then spend another hour looking for a parking place. If we could rapidly get people to go to where there's open parking, you could get people off the roads quicker. Certainly that makes the people driving the cars happier. So when they go to the event, they're happy instead of pissing or cussing and sweaty, upset with their efforts to find a parking spot. But it also gets vehicles off the road, that reduces congestion, that makes fewer accidents. So there's a whole lot of benefit to doing this. But the trick is, the problem is you got to take data from all these different parking places with different technologies and find a way to integrate it together. So here the idea was to use i3, build interfaces from that to all these parking options, and then set it up so that maybe the data is then fed into maybe Waze or something like that. So if you're using your navigation app, instead of saying, do you want to go to the Staples Center, maybe it gives you an option and says, did you really want to go to the Staples Center, or you want to go to a parking place near the Staples Center? And if you go to a parking place, it'll route you to a place where you have a high probability of finding parking. This also starts to open up ideas, and we haven't gone too far down this road, but the idea of being able to reserve parking spaces, even though maybe the vendor doesn't have a lot of technology, maybe he's got a video camera or something, but how can we start doing that? Or how can we have concierge parking, where maybe you get a bottle of water when you arrive, just to let you rehydrate. Maybe they wash your car. There's lots of things that could sort of build after that. One of the things we're working on, and we're doing this in Hollywood. If you're familiar with Hollywood, Hollywood is a bunch of independent mom and pop stores. spread up and down the street. Each of them has their own technology, so it's a very federated environment, and they can tell what's going on in their store, or maybe what's right in front of the store. But they don't have visibility to kind of what's going on in the neighborhood. So the idea here that we're working towards is being able to take the data from each of these independent stores. By agreement, we fill that data into a business district data lake that sort of provides sort of a neighborhood view as to what's going on real time. And then maybe there are applications on top of it that use that data to sort of change even some of the way the stores operate. For instance, if a store has an in-window advertising display and you know that, between let's see, what is it? Between noon and 4 o'clock, that's when the tourists are in Hollywood. So you sort of orient all your advertising toward the tourists. Once you get toward the dinner hour, you get the people who are out looking to have a nice dinner and enjoy themselves. Then when you get really late at night, the demographics actually change again to being much more the party, high energy scene. So just by being able to sense the mood of what's going on in the street and what's happening, the stores can sort of optimize what they're presenting to their customers in real time. And that's kind of what the project is. But you have to do this, you have to have a view bigger than what the individual store can see. One of the things we've talked about, and this is still really in its infancy, there's a concept in healthcare called data without walls. Most people, when they think about applying technology automation in the healthcare system, they're thinking about, most of the conversations are about improving the relationship between the doctor and the patient, or they're about improving the operations inside the hospital. But what we're trying to think about is, what if healthcare is not facility centric and it's really made up of a network of other people, some of them being healthcare like hospitals, doctors, ambulances, but also some of it being just social services. Whether people get their food or not, that Meals on Wheels, that's a healthcare issue. But so how do you take all these different services, pull them together to build a more comprehensive view of the healthcare in a specific community, and sort of how do you manage health at a community level? So how to pull the data together. So that's something that we're sort of looking into as well. We've done a little bit of work, not much in the area of smart buildings. If you think about smart buildings, well, there's smart buildings that are owned by one person who sort of controls everything, but in a lot of high rises, each floor might have 10 or 12 different tenants inside of it. So in that case, each tenant is really has their own independent IT. There's the building functions. How do you start taking all these individual tenants, pull it together, tie it into the building system, and then start providing a level of service that is more than just the commons, or that's more than just what is in the individual office. Since I am kind of running out of time and I want to leave a little bit of time for Q&A, maybe I'll skip this slide. And real quick, and this is just something we sort of realized as we were going down this path. A lot of the pictures, as we were drawing these ideas out, we began to realize the images that we were drawing actually look, in the IoT space, a lot of it looks like the early days of when the internet first emerged, where if you think about the days back when AOL would tell you, here's what data is available, here's what you can do, blah, blah, blah. And that was good, that was fine. But the internet didn't start to evolve and take off, explode, until really we let people go anywhere they wanted to, do whatever they wanted to. And they started actually creating that thin waist picture that I showed earlier. That's how they started drawing internet and saying, here's how we explain the internet. And we're basically realized that we're sort of saying that in the IoT space, it's going to follow technically an architectural structure that the internet followed. We're just several years behind it, and we're trying to sort of facilitate that evolution as we look forward. And I will pause here because I wrote this assuming we would have a bunch of students on. I'll leave these up if we want to talk about them, we can. But what I'd rather do is pause and sort of open it up for questions. And if you have no questions, you can read the slide.
Very interesting talk, very interesting work. So I guess, are there questions that people have for Jerry?
Yes, I can start. Yeah, so that's very insightful. I think of like one point that I'm trying to kind of like also get your insights on is that when we think about these IoT systems, it's a lot about IoT devices or kind of like at least or even virtual devices that are on the edge, kind of like close to users. However, what is the role of placing compute and storage on the edge as well? Do you see that there is kind of like opportunities or value in doing this, or are we still doing compute and storage still in the cloud or somewhere far away?
Let me answer it. Your question's a fascinating question, but let me answer it two ways. For the most part, although there are exceptions, we are still doing everything in the cloud today. I think we are on the cusp of starting, and we started, I said, except for a few, so there are a few brave souls who are sort of out working toward the edge to do things. I think we are on the cusp of seeing a pretty significant shift in that direction. And I'm saying this because some of the people I talk to, I'm aware of some things that are happening that are really kind of mind-blowing, because once you start putting more compute power in the IoT devices or in front-end processors, it really sort of completely changes the way you think about these things. So to answer your question, today I think we're still largely stuck in that cloud client server structure, but I think we're about to make a big swing.
I see. Thank you.
So Jerry, I was actually curious about a few things. First, what's the relationship of i3 to USC? That, and if there is any, like, is it a USC formed company which is partially owned by USC or something, or where are you getting your, I guess, funding from? Second, you showed a lot of very interesting sort of use cases of the technology, ranging from Hollywood to sharing of information across stores to basically medical stuff as well and so on. Are any of these sort of more well along as compared to other things?
Yes. Okay. Let's take the first question. The first question is the relationship to USC. We released the i3 software while I was at USC as open source, so that's publicly available information. So there's really no intellectual IP tied to USC. I'm certain of that. In fact, the licensing all is pretty clear. And we said when we started doing this, we actually said we want to do this as open source. So this is not something and Bhaskar and I were looking to make a lot of money on. So there's no real intellectual tie to USC. That said, i3 Systems does have as part of its mandate a desire that, well, once we get profitable, to start giving back to academic institutions, because we realize that we wouldn't have made it even this far without support from academic institutions. And I'll say, I'm saying it as academic institutions, that it's not tied specifically to USC. So that's kind of an open thing that we want to be able to give back to that organization. The i3 Consortium, which is a different organizational entity than i3 Systems, that is run as a nonprofit, but under the USC umbrella. At some point in time, the intent is to sort of make that nonprofit and sort of split it out into an independent nonprofit. But we haven't really started taking many steps in that direction. But as what we're doing grows, we think that sort of seems as academic institutions become involved. We think there's sort of this natural evolutionary step to take what started as a USC nonprofit and move it out. We do think that if you think about what I3 is, it is a very thin layer of enabling software, but it enables some really interesting research projects to occur that might not have happened before. So we do think that relationship to academia is an important thing for us in that research, because we don't want to put a lot of time and energy into research ourselves as much as being able to commercialize the software. But also for more than one academic institution. Now I forgot the second question.
No, are there some projects which are much further along compared to others?
Okay. So the parking project was done. That's completed. The city actually developed that application themselves, so it's their application. I don't think that they plan currently to release it to the citizens for public consumption, but at some point in the future, that might be something that happens. How many projects the city takes on is dependent on their funding level. So I think there's still some open room there. The thing I mentioned about the sanitation truck, that is very much an active project. We'll probably be working on a proof of concept in that space over the summer and into the fall with different phases. We're still working on exactly what those phases are. But those are probably the two that are farthest along. A lot of the other conversations, the one about the stores, that conversation's pretty far along, but the company that's doing it, it's a startup, and they're sort of out looking for funding. Oh, and your question, the other part of your question was about funding. So far, i3 Systems has been totally self-funded. We were able to get to where we are. We're able to get, and we think we can support 3-4 customers with the resources we have. But as we start scaling and delivering the software to other people, that scaling will pretty soon begin to fall apart, and we will need to go to external venture capitalists. And I'm sort of just starting down that process of trying to find investors. I've found, quite honestly, a couple of secondary investors who want to be part of a syndicate that invests in i3, but I haven't yet found somebody who says, I want to be the lead investor on this project. Once we do, our intent is to scale, not just in the United States, but I mean, the intent is to make this a global product.
So Jerry, this is Nandini. I have a question. Somewhere along the way, you mentioned that there was a bit of effort that went from taking it to efforts that were developed by groups of students into something that a company is putting together as a product that you're trying to get out there. So what were the challenges that you faced? We have a lot of students on the talk here, and it would be nice to sort of hear your experiences in translating that software. And second, maybe if you can give us, if it's not proprietary, some aspect of what were the technology building blocks that you used within the system, within the data exchange? Was it open source? And to what extent did you leverage the use of open source software?
Okay, so I would say the biggest stumbling block as far as the use of student labor was that students worked on this project because this was a multi-year project that spanned a number of years. Students would come on the project, work for a semester, then I don't know, they get hired, they get a different job, they would something. So the students, basically, you could almost see in the way the code was written, you could see different students did different parts. Quite honestly, the students did a really amazing work. But the issue became that the code, they did not all have the same documentation standards, and we didn't think to enforce documentation requirements. So when something broke later in the process towards the end, and you had to go back and figure out how to fix it, the students would have to go back and sort of get their head into, well, these 3 other students worked on these other projects that feed data to me, take data from me. You'd have to sort of go back and try and figure out how they did things. And there was no documentation standard. So the students really started spending increasingly a growing amount of time trying to understand what prior students had done. If I think, quite honestly, if we probably would have said, here's a documentation standard that you have to follow, it probably would have been a whole lot easier. The other thing too is that because when we were working on this as an academic project, the goal was usually to get to a demonstration system. And if that's the goal compared to a commercial system, you pick different open source software. And we do use a lot of open source in the software. I probably can't go through on this phone call and give you a list of all of them, but we do. So we make a lot of use of open source. But there are places we've also have the capability of, if somebody has a value added module that they want to sell, you plug it in, but it costs money. That can happen as well. I feel like I didn't quite answer your question completely. So because the system at USC was designed sort of around demos to prove the idea worked, we selected different open source software modules than we selected when we put the commercial version together. You look at different things like scalability, reliability, and things like that when you're looking at a commercial version. When you're really building a demonstration version and there's still a lot of open unanswered questions about what you want to do, you start looking for things like open source that gives you lots of flexibility, that lets you quickly try and do things. And if you need to change to a different direction, you change to a different direction. It turns out like the motivation of what you're trying to do in the end actually has pretty significant impact in impacting what open source projects you pick.
Interesting. Thank you.
Jerry, Dan Whalen here. It's not clear to me what your business model is. Early on, you mentioned Red Hat from a sort of a support perspective. Is your product an open source product that you're providing for fee support, or what is your business model?
No, we are not. We're not the software that we're selling the software. So it is, it's buy it. Our intent of i3 Systems is to make the software available online, let people pay for it, download it, and go off and run it. If they want the open source version, they can go back and use the USC version. That's fine. And for some cases, that's actually maybe the right thing for some people to do. But if your intent is to long-term deploy this in an operating setting where you really don't want the software to go down, you want to make sure it can be supported, then you probably want to be looking at what we're doing.
Okay, and can you elaborate a little bit more on the functionality? I mean, you kind of maybe hinted that it might be like a pub/sub model, but I'm not sure what it is.
It is pub/sub, and at the very core of the system, there's a pub/sub message broker process inside of it. There's a lot of software around it that manages the negotiation process that goes on to enable or to turn on or turn off the pub/sub data flows. So while pub/sub is the heart of it, most of the work that we put into it is stuff around that. The pub/sub stuff came pretty easily.
Thank you.
Other questions? Nalini, you still have your hand raised. Are you wanting another question? You forgot to turn it off. Okay, she turned it off. All right. Okay. Anything else? So, Jerry, I do have another question for you. So I get reminded a bit of C3 IoT or C3 AI, right? Do you see any overlap with those guys as to what you're doing, or there's not much overlap?
I'm going to say I don't see that there's any overlap. If you ask them, they would probably say there's a lot of overlap. How's that for a conundrum of an answer?
That's the honest answer. I can understand that.
So a lot of people who are doing IoT systems, if they're trying to keep their costs down, they have to sell volume. So a lot of them, either on the application side or on the device side, are building systems so that they can control the ecosystem. They can determine who plugs in or who doesn't. And that way they make sure they keep getting paid. Whereas we've taken a different philosophy and sort of said, this is a very thin layer. If you buy i3 by itself, that it has limited value. It's when you put it into a larger solution that the value begins to become apparent. Whereas some of the companies you mentioned, their goal is let's do everything in a box. That way you just come to us, you've got one throat to choke. And that's a valid way to think about it. But we sort of came up through, as we were emerging, like I said, the city of LA had a lot of influence in shaping the way we thought about this. And the city of LA is pretty adamant that they don't want to be locked into any single vendor. And in some cases, that means they want to have actually two vendors for everything so that they can sort of play them off against each other. So in that kind of environment, we sort of stand out compared to somebody who's trying to do everything and say, look, I think GE was trying to do that, AT&T and Verizon were trying to do that for a while. But I think that single purveyor of systems that might work for a strong IT, but when you're looking in a federated environment, it kind of begins to fall apart.
Okay, so I guess there's one last question which I think Mike had posted. I guess he's not able to speak, so let me speak it for him. So he's trying to find out, is this something, the PubSub part of it is something that you guys developed on your own, or you built on top of an existing?
No, we use somebody else's PubSub broker. And right now I'm having a memory lapse, so I can't think of who it was. But we did use somebody else's. We actually spent a fairly exhaustive time looking at all the different PubSub options that were out there.
Okay. Thanks. I'd be curious to know which one when you once your cache loads.
Yeah, if you send me an email, I'll look into what it is.
Okay, thanks.
Was it primarily for the IoT data, the broker, or was it for other types of bigger types of data as well, or did you have multiple of them? Because was it like mosquito or?
Oh, it was definitely not mosquito. We
eliminated that one
and decided it wasn't appropriate for what we were trying to do.
Kafka.
Yeah,
I was thinking Kafka too, but
Kafka is not free though. Kafka is paid. Like it's not open source, right?
No, there is open source.
It's open up to Apache.
And I don't think it's Kafka, but I know we looked at that also.
Well, Kafka from Confluent is not free.
Yeah, that's what I had in mind. Because of Hajat, it's sort of automatically think of Confluent.
There was a part of that question that I didn't answer. I'm good at remembering whether I answered all the question fragments, but I don't remember what the fragments were.
You got mine.
Yeah. Good, Mike, you were saying something.
Yeah, no, like there was no unanswered fragment in mine.
Yeah, except when you find out, I think we'll all be very curious to see what was the system that you guys used for this. All right, let's thank our speaker. We are 5 minutes over I guess we started 3 minutes late. We are 5 minutes further late. I think we're intruding in somebody's meeting with you. This is a time when we'll be clapping, but since it's virtual, I think Roberto and Faisal and Nalini have done the clap and Mike has given a thumbs up. All right, I'll clap on everybody's behalf. Hopefully you can hear me.
Let me just add at the end, I think I sent a letter of support. It was a project you were doing with Bhaskar.
Yes.
And then you and I talked after that.
Yes.
At the time I was sort of, if there are students who are looking, if there are students who are interested in sort of working on this with us, we are looking for some good computer engineers. We don't have money. Right now we're still sort of operating kind of in like the Hyperloop model where everybody's kind of working for equity. But if somebody, it is good experience if somebody's looking to put it on their resume, and if somebody's really interested in doing something innovative in this space, feel free, that you would recommend, I should add that there, feel free to send them to me.
Absolutely. Absolutely. All right. Thanks, Jerry. I think you have a schedule ahead of you, right? You have a few meetings ahead of you.
I know I have a meeting. I'm looking to bring it up now.
All right.
Here it is.
All right. So we'll catch up a little later. I'm meeting you, I think, a little bit later on.
All right. Sounds good.
Talk to you.
All right. Bye-bye. Thanks, everybody.
Bye.